Good day to all. Today our topic is genetic algorithm. Genetic algorithm is used to identify the best solution for engineering problems and also science problems. Here we can identify the best solution from natural selection process. So genetic algorithm is also called as one of the non-traditional optimization techniques. The artificial intelligence techniques utilizes planning, natural language processing, speech processing, machine learning, engineering and expert system, fuzzy logic, models of brain and evaluationary techniques, machine vision and robotics. In that, models of brain and evaluationary technique utilizes the genetic algorithm for identifying the best solution for the respective application fittest of parameter to the considered objective function of the process, which is the need of a genetic algorithm in engineering problems. So models of brain and evolutionary technique identifies the genetic algorithm for getting the best solution by the incorporation of natural selection process as like our genetical functions. Here, GA is non-traditional optimization technique which follows population of the points are involved in initial populations and which follows probabilistic in nature. Probabilistic in nature means the genetic algorithm follows the random number generation through Monte Carlo method, which also follows the natural behavior of our chromosomes. For example, if you are consider our human generation in that male chromosome and female chromosome joined with each other and make a child. How the child could be based on the male chromosome and female chromosome interactions or combinations. Here the three operators are placed. I will explain what are the operators that are involved in a generation of child. But the father may be blind, mother may be good, but we need a good child. In our genetical manner, there should be a possible of a blind child or good child. How can we get the good child, which is the problem? So the problem solving technique follows the genetic algorithm. In that we should avoid the blind child, but we always make a best one from the chromosomes, male chromosome and female chromosome. We can get the best child from these genetic operators. So we should aware about the genetic algorithm operators. GA starts with the population of strings, thereafter generates successive population of strings with three operators in many practical problems. So the GA operators are named as reproduction, crossover, mutation. I can explain what is reproduction, what is crossover, and what is meant by mutation through manual calculation of genetic algorithm. For example, if you are consider the problem as like toss. In cricket playing, there is a toss gaming is available. In that gaming, we can the players can start randomly flip the coins. In that, the successive coin flips are occurred. If the head falls, we may assume that is 1. If tail falls means we may assume that 0. So that from this generation we can generate n number of population. For example, if I consider the 4 populations, according to this example there are 4 strings are available. If the first flip of coin is tail, so that I place 0. After that I flip the coin again, I get head, so that I placed here 1, and then again I flip the coin, I get the head values. So that likewise I cyclically change head and tail values. From this I can get the smaller string, so 0 1 1 0 1. Likewise I may get the string, so which is the population number 1. I consider this generation the population number n is equal to 4, so that I flip the coins at different times with the 4 different positions, so that I can get 4 strings from the coin flips, which are 01101, 11000. Based on the coin flip, I can get the different strings, which is the initiation of population in a genetic algorithm. After that, what is reproduction, what is crossover, what is mutation? Let's see. Reproduction meant by worst is replaced by best one. It is a process in which individual strings are copied according to their objective function values. I will explain with the practical example. From this you may aware what is reproduction. In that, how can we copy the strings with respect to the fitness values. Likewise, we can understood after performing the reproduction operator in our manual calculations. After that, second operator is a crossover. Crossover means new populations are generated based on the reproduction operator functions. After reproduction, simple crossover may proceed in two steps. In that, first step is members of the newly reproduced strings in the mating pool are mated at random. Second step is each pair of strings undergoes crossing over as follows. An integer position k along the string is selected uniformly at random between 1 and the string less than 1. So two new strings are created by swapping all characters between positions k and 1 inclusively. Let's see how can we perform crossover with manual calculation. We can understand. Here you see one of the examples that is available with how can we perform the crossover. Already you know about how can we develop the string with the flip of coin. Likewise, I may generate two strings. The string 1 is called as A1. A1 is equal to 0, 1, 1, 0, 1. After that, second string A2 is equal to 1, 1, 0, 0, then 0. After that, I may select the random number. And get the random number between 1 and 4. I can get the random number as like 4, so that after fourth digit from the string I can start and I draw the straight line. After the straight line there is from first string there is 1 and in second string there is 0. So I can interchange the place of 1 and 0 with each other, so that the A1 is reframed as like A1 is equal to 0, 1, 1, 0, 0, because here 1 is replaced with the 0 from A2. Likewise, we can interchange the place with the A2 string also. Here 1, 1, 0 available, so I reproduce 1, 1, 0, 0. After that, there is 1 is to be replaced for 0. Here I can interchange 0 with 1, so that A2 is reframed as like 1, 1, 0, 0, 1. Likewise, we can perform the crossover operator in genetic algorithm. So the crossover mechanism involving random number generation, string copies and some partial string exchanges as like this A1 and A2. After fourth bit we can change the fifth bit with each other. And then mutation. Mutation means locally and hopefully tested. Reproduction and crossover effectively search. Also the mutation is needed for avoiding of loss in useful genetic material, which means in string there is a 0, 0, 1 or 1, 1, 0. Likewise, lot of bits available. We can change the bit 1 value it into 0 and 0 value it into 1. Likewise, we can change the string values with the genetic material. From this also we can change the random number value. So the mutation operator protects against such an irrecoverable loss. So mutation operator always safeguard the irrecoverable losses from the population or mating pool. So mutation is a random alteration of the value of a string position, which simply we can explain, which means changing 1 to a 0 and vice versa. For example, if you are considered the bottom of the slide, there is 0, 1, 1, 0, 0 available. randomly I select the random number means I got 4, so that I put the square box with the fourth digit in blue color. In that blue color there is 0 available, so I can change that 0 value it into 1. So likewise we can change the square box values from 0 to 1 or 1 to 0. Likewise we can interchange the values or change the values. From this we can protect the irrecoverable losses from melting pool. After that, yes, how do we solve the genetic algorithm manually? Let's see. For understanding genetic algorithm manually, we consider the maximization problem. So our objective function is maximize z is equal to 2x1 plus x2 power 4, subject to the constraints 0 less than or equal to x1 comma x2 less than or equal to 9, which is the constraint equation. For solving this problem, initially I have assumed as like bit length is equal to, always I assume the bit length with the even number, so that generally I may select the bit length as 8 to 10 and then cross over probability. So genetic algorithm follows the probability calculation, so that crossover has its own probability from 0.5 to 1, and then mutation probability is always lying between 0.01 to 0.1, and then we may assume the number of population. Then according to this problem I assume the number of population is 10. For understanding purpose only I will take the class genetic algorithm class, so that I consider number of generation or iteration is equal to 1. And then initial step, the problem is given, so that the initial iteration is to be started with the x1 and the x2 evaluation. So that how can we identify or find x1 and x2? Yes, I follow the formulas like x1 is equal to x1 minimum plus x1 max minus x1 minimum divided by 2 power L minus 1 into random number. Here what is x1 minimum, what is x1 max? According to the given problem, x1 minimum is 0, x1 maximum is 9. So here I can place x1 minimum is 0, x1 maximum is 9. Here what is this? Yes, here 2 power L is available. What is L? Yes, bit length. Here we may assume in between 8 to 10, so that this problem I assume bit length is equal to 8, so that here I can substitute 2 power 8 minus 1 into random number. In problem I will tell you how do we generate the random number with the examples. After that we should find the next parameter, because this problem has two variables which are x1 and x2. For the reason I should find x2 also. Here x2 is equal to the same formula, x2 minimum plus x2 maximum minus x2 minimum divided by 2 power L minus 1 into random number 2. Okay, here also I can utilize here, because the objective function subject to the constraints 0 less than or equal to x1 comma x2 less than or equal to 9, so that the x2 variable also has its own lower limit value as 0, minimum value is 0 and maximum value is 9. So I can substitute the same value here also. So here solution accuracy I can calculate from this formula x1 plus x1 max minus x1 min divided by 2 power L minus 1. From this x1 minimum is 0, from the problem x1 minimum is 0, x1 maximum is 9. So I can substitute 0 for x1 minimum, 9 for x1 max. So 0 plus 9 minus 0 divided by 2 power 8 minus 1. From this I can get the solution accuracy of 0.03529, which is the important step that is available with the genetic algorithm initial population generation. And then what is fitness function? Yes, the fitness function. Our problem is maximization problem, and also in our engineering problem minimization is also available. For I consider the productivity means I should maximize. If the production cost means I should minimize. So that two objective functions are available with the engineering problems. So that here how can we arrive the fitness function for maximization problem? Yes, the capital F is the fitness function. If I utilize F is equal to f of x means maximization problem. Here I may consider the fitness function is equal to 1 divided by 1 plus f of x means I consider this fitness function formula for minimization problem. So engineering problem are always has two extreme level. One is maximization problem, another one is minimization problem. So if I want to identify the fitness function means I may utilize f is equal to f of x for maximization problem, capital F is equal to 1 divided by 1 plus f of x for minimization problem. Likewise, we may consider the fitness function formulas. The example problem solving by using genetic algorithm. Yes, I want to start the genetic algorithm manual problem for your understanding purpose. For the reason, I can generate initial randomized population with the random number 1 to 100. How can we perform the randomized population? Let's see. Here I may introduce one table. The table is like serial number 1. After that, second column is random number 1. After that, substring 1, which is the general structure I told. After that, I will explain what are all the content that are needed for fill the tabular column. After that, random number 2 and then substring 2. Likewise, I may create the initial table for genetic algorithm problem. After that, for this problem, I consider 10 populations. So that serial number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, I generate the 10 populations for solving this problem. And then how can we generate the random number? Here I generate the random number as like 14. How did I generate this 14? Let's see. With the calculator only I generate this random number. And how can I generate this random number? Yes, this video places the calculator. Here I press 100. After that I press the shift button that is available with the calculator, and then random mash symbol. After that equal to symbol. There is 80.3 and 48.4, 13.2, 4.7, 10.1, 32.9, 57.5, 22.9, 27.9, 32.9. Likewise, there are n number of random number we can generate with the aid of calculator. Yes, after that I can generate the 10 random numbers because I consider 10 as a population size. So that I generate the 10 random numbers. Then next step, I convert this decimal random number to binary number for substring. Here, how can I convert this decimal random number to substring number? Yes, here you see I generated as like 0 0 0 0 1 Likewise, I generated the substring numbers. Here 8 digits are available. Why I selected 8 digits? Initially I consider the bit length of this problem is 8. So that I substituted 2 power L minus 1. For L value I substituted 8. 2 power 8 minus 1. 2 power 8 is equal to 256. 256 minus 1, 255. Likewise, I substituted. From this, I may get 9 divided by 255 is equal to 0.03857. Likewise, I got the solution accuracy. So, here I generated the 8-bit substring value. How can I convert this 14 as a decimal random number into substring value with the binary number? Let's see with this video. Here, right? press the mode button, there is SD register base. I go to base function. In that there is in B. Likewise, the presentation is available with our calculator, and then I convert this with the decimal number in your calculator there is available. So that I press 55, so which is the decimal number. After that, in calculator there is BIN. Likewise, button available. If I press, I can get 110 Likewise, I may get the bit value or binary value here. Now I enter 69 as the decimal value, so that I press decimal D, and then I convert this it into binary number, so that I press the binary button that is available with our calculator. Now I may get 1000101. Likewise, I get the binary values from the available decimal value. Likewise, you may convert the decimal value into binary value. Here I convert all the 10 populations from decimal value to binary value with the aid of calculator. Likewise, I generate the 10 substring values from the 10 random numbers. After that, random number 2, because I have two variables such as x1 and x2, so that I generate two random number values. For the reason I may generate random number 2 with the available table. Here also I can get 10 random numbers from the calculator. After that, I may convert this random number into substring values as like random number 1 with the aid of calculator. I convert this decimal value into binary value. For 23, I get 10111 I may get, but in my problem I consider 8 as a bit length, so that before 5 digits I introduce 3 zero values. From this I can get 8 digit values. And then 11. For 11, the binary value is 1011, but 4 digits only available with 11 as a decimal number. For the reason, I may introduce 4 zero bits in before of 1011. From this I can get 8 bit values for this random number 2 as a substring 2 values with the population number 2. After that, population number 3, there is 91. I convert this and I can get the binary number value, and also I change all other 10 populations. I convert that decimal random number into binary number with the aid of calculator by the following of same procedure. Next step, to find x1 and x2 and f of x for all populations. So initially I find random number 1 and random number 2, and what about x1, what about x2 and f of x value. For the reason, I may utilize two formulas as like initially I told you. X1 is equal to x1 min plus x1 max x minus x1 min divided by 2 power l minus 1 into random number. Here x1 is equal to 0, minimum is equal to 0, x1 max is equal to 9, so that 0 plus 9 minus 0 divided by 2 power 8 minus 1. I again generate the random number with the aid of calculator. What I told already, I shows the example how we generate the random number with the aid of calculator. You may follow the same procedure for generate the random number. Here I got 14, so if I multiply 14 with the solution accuracy, I can get the 0.4941 as the x1 value. Next step, I have to find out the x2. Here for identifying the x2, the same formula, x2 is equal to x2 minimum plus x2 max minus x2 minimum divided by 2 power l minus 1 into random number 2. Here I already know about x2 minimum value is 0, x2 maximum value is 9, and 2 power l value is 8. Likewise I know, but what is random number 2? I again utilize the calculator and generate the random number. From this I can pick the random number 2 value. So 23 I got from the calculator. From this I may get the x2 value as like 0.8118, which is the initial x1 and x2 point for the initial 0th iteration. So for serial number 1, I should identify the f of x value. The f of x value is identified from the given problem. The given problem is maximize z is equal to 2x1 plus x2 power 4. Here I can substitute the x1 value as 0.4941, x2 value as 0.8118 power 4. From this I can get 1.4225 as the fitness function. Here I consider which is the maximization problem. So the fitness function capital F is equal to f of x. So fitness function is 1.4225. Likewise, I can collect the value from the given problem and initially generated populations. The problem is maximize z is equal to 2x1 plus x2 power 4. What is the next step? Let's see. Here the serial number. We are in our problem we are having 10 population size. So we may give the serial number as like 1 to 10. After that x1. For every population we should identify the x1 value as like before the step. After that x2 and then finding the f of x for 10 populations, and also we should find the fitness value. Here you see the 10 populations 1 2 3 4 5 6 7 8 9 10, and then every population I should generate the x1 value, x2 value. For the reason already I told about how the 0.4941 came. The same formula I utilized for generate the x1 values for each and every populations, and similar to same x2 value also generated with the same formula x2 min plus x2 max minus x2 min divided by 2 power l minus 1 into random number. So for every population we should generate the random number. We can multiply that random number with the solution accuracy. From this we can get this 10 x1 value and 10 x2 value. From this identified x1 and x2 value we can find the f of x value for each population. Here I can substitute the second population 2.3294 as the x1 value in this objective function, so that 2 into x1 plus x2 value is 0.3882 as the we can substitute as x2. From this I can get the maximize z value as 4.6815. I should find all other population values that are available with this matching pool. So I can get the 10 f of x values. Here we are considering the maximization problem. So fitness function value capital F is equal to f of x. So I can get the same f of x value as the fitness function. If suppose we are having minimization, means the separate formula is available to convert the f of x value it into fitness function as like 1 divided by 1 plus f of x. But this is the maximization problem. So we can utilize f of x is equal to capital F, which is fitness function here, so that I can utilize say the same f of x value for all other populations also. So the same f of x value as the fitness function value for maximization problem. So what is the next step? We should sum the all fitness function value for arriving the next step. For the reason I sum up all the fitness function values with each other. From this I can get 481.6387, and then for moving the next step I should identify f bar value. F bar is equal to sum of f divided by population size. Already I sum up all the values that is available with the mating pool. Here 481.6387 I got. Here f bar means sum of f divided by population size. According to this problem I considered population size as 10, so that 481.6387 divided by 10 I can get 48.16387, which is the f bar value. Why I should identify f bar value? Let's see with our next step. Yes, here the tabular column available. In the tabular column there are a lot of functions we should performed. This tabular column is known as reproduction operator. How can we perform reproduction operator? Here also I introduce serial number as like the same 1 2 3 4 5 6 7 8 9 10. Okay, after that capital A. What is, which is the generalized formulation that is available with the genetic algorithm? A is equal to capital F divided by F bar. Here capital F means fitness function, F bar means sum of F divided by population size. In previous slide we identified the F bar value, and each and every population has its own fitness function value. Here the each population fitness function value is divided by F bar value. So here you see, according to first serial number, there is 1.4225 as the fitness function value, divided by F bar value is 48.16387. It's equal to 0.0293, which is the population first A value. Okay, 0.0293. Then second population, so same the thing I followed, the same F value I substituted from previous slide. What I identified as a fitness function I substituted here, divided by 48.16387. From that I can get the values as like 0.0972, and then population 3 2.3237, population 4 0.1441. Likewise I will be conducted all the 10 populations. I may get the capital A value. After identifying the capital value, I can move to identify the capital B value. Capital B is equal to A divided by population size. Here every population has its own A value. For example, if I consider the first population has the capital A value is 0.0293, and the population size is 1 to 10 available, so that the first serial number B is equal to A divided by population size is equal to, here I have 0.0293, so that I substituted 0.0293 divided by the total population is 10, so 10 is equal to 0.00293 for the first population's B value. Likewise I can calculate other populations B value also. From this I can get the 10 different population size values, B values. Okay, after that C. Next we should identify the C value, which is also one of the procedure for conducting the reproduction operations in a genetic algorithm. What is C? C is the cumulative of B. For considering the serial number 1, the serial number 1 has a 0.00293, so that I can reproduce the same as the C value. But if I consider the second serial number, already there is 0.00972 available, so I have conducted the cumulative value 0.00972 plus 0.00293. I should conduct this calculation. From this I can get 0.01265. Yes, I got the second population's C value. And then what about the third serial number? Here you see there are two values, 0.00293. In second population there is 0.00972, and then in population 3 is, population 3 there is 0.2327. Likewise three different values available. I sum up both the things, I can get 0.24502. Likewise I can get the C value for third population. The similar procedure I followed for other serial numbers, which are 4th, 5th, 6th up to 10th I conducted. I can get the 10 C values for different populations. After conducting the C identification, we should move to identify the D. D is the generate random number between 0 to 1. Why I conduct this? Let's see how I conduct this step and what can we get from this D generation. Yes, initially I got the random number between 0 to 1. Already I told about how can we generate the random number with the aid of calculator. From this you may select the random number. I got 0.257 as the random number with the first population, and then second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So 10 random numbers I generated for framing the D values with this genetic algorithm table. After that, E is compare this generated random number to available cumulative value of B, okay, which is C. Here you see the D value is 0.257, which is the most nearest value. Here 0.00293 is not nearest value, 0.01265 is not a nearest value of 0.257, and 0.245 is more slightly nearer to 0.257. The most nearest value is available with this table, which is 0.25943. So the most nearest value that is related to 0.257 is 0.25943. The corresponding serial number is 4. So that I represented here 4. After that, I may compare this 0.589 to the available other values that are C. Okay, I compare, and then seventh value 0.44779 is the most nearest value with respect to 0.589 than 0.95136. So the corresponding serial number is 7. So I place here 7 as the E value. Likewise, I conducted other D values with the C value comparison. I can get the E value for every population. The same procedure you may follow for every populations. From this, we can find the reproduction values, which is the reproduction operator that is available with the genetic algorithm. After this, after reproduction operator, we should perform the crossover operator. So I can reproduce the same E value, which is collected from the previous slide 4, 7, 3, 7, 10. Likewise, I generated the same serial number I collected from the previous slide, and their own then associated substring values. What is the fourth population substring value from those previous slide I can collect. Okay, thus reproduce the same values. Fourth serial number, the substring values are like 0, 101, 1011, 000, 11, 000. Likewise, in previous slide available. Let's see. Here you see 0101, 1011, 001100. How can I collect these substring values? Let's see from the previous slide. Fourth serial number. Okay, here you see fourth serial number 0101, 1011, 0001, 100. Likewise, I may get the substring values 1 and 2. The same thing I reproduce with this table also. So here I can reproduce the same E value from previous table, and then substring values collected what I told you earlier. So we can collect the substring values from the previous one. So I can reproduce. Here, how can I perform the crossover function? For conducting the crossover function or operator, I may generate the random number between 0.8 to 0.1, because our crossover probability is 0.8. For the reason, I may generate the random number 0 to 1. Okay, here first random number is 0.7, 0.3, 0.7, 0.8, 0.6, 0.4, 0.7, 0.1, 0.3, 0.2. Likewise, I got the random number between 0 to 1, which is the initial step that is available with the crossover operator. And then what is the function next? F value identification. If the probability value is less than 0.8 or equal to 0.8 means we should conduct the crossover function. If the value is greater than 0.8 means we won't go for crossover function. Here all the values are less than 0.8 or equal to 0.8, so that for all the populations we should perform the crossover. Then how can we perform the crossover? Before performing the crossover function, we should ensure we should perform the crossover or not from this f value. After that, how can I perform? Yes, for performing the crossover, I can generate the random number between 1 to 16. For the reason, I may generate the random number. The initial population can get 7. Here, the how can I? Yes, the for population size 1 and 2. Every time I can perform the crossover with the two populations. So for first pair 1 and 2, I can choose I can generate the random number as a 7. So here one first substring there is 8, the second substring also 8, so that 16 numbers are available. From this 16 number I got 7. So here bit values are 16. For the reason I may choose the random number between 1 to 16. Here 7 is the first population I generated. So here the first 7, 1 2 3 4 5 6 7. After 7 I may produce the straight line. After that the red color digits are available. In that we can interchange this red color from place to place, upper to lower, lower to upper. Likewise we can change the places of bits from one population to another population within the considered pair. After that the second pair is also available. The second pair is second population and third population and fourth population. Here I got 13 as the random number. So in first substring there is 8, the second 9, 10, 11, 12, 13. After that I may give the line. Then after 13th digit there is 3 digits are available. The 3 digits are interchanged between them, which is the crossover function of second pair that is available with our mating pool. After that the third pair, which is fifth and sixth, for the reason I got random number 14. After 14th digit I can interchange the values. And then for the 7th and 8th pair I can get the 7 as the random number, so that after 7 I may interchange the places. Okay, from this we may perform the crossover operator with the available mating pool. Here the last pair, which is 9th and 10th, I got 11 as the random number, so I can interchange the strings after 11th bit value. Here red color shows the after 11th values, so that the red color values only we can interchange from 9th to 10th, 10th to 9th. Likewise we can interchange. Then I make it after crossover, I can get the substring values. I reformulate the populations tabular column. Here after crossover we can move to mutation operator. The mutation operator, we have to identify the mutation size. How can I identify the mutation size? From the available formula, mutation size is equal to population size into bit length into mutation probability. In our problem we consider the population size as 10 and bit length as 8 and mutation probability is 0.1, because mutation probability always lying between 0.01 to 0.1. According to this problem I chose 0.1 as the mutation probability. So I substitute all the values in the corresponding formula. From this I can get 8 as the mutation size. So here I should perform 8 sites as the mutation, 8 sites for mutation performance. Here how can I perform mutation operations? Let's see. Here I got 8 as the population size, so that I should generate the 8 random number. I divide that 8 into 2, so that because I got the 2 substrings, so that I divided that 8 into 2 portions, 4 portions and another 4 portions. Here I should generate 4 random numbers for every bits. Here a first decimal number has 8 bits, so that first random number I generate between 1 to 8. Then second random number I add a substring 1 and a substring 2. I got 16 bits. So the second 4 mutation sites I can select between 1 to 16. Here 1 to 8 I generate the random number. In that I may got 6 as the first random number. So I should choose sixth population for conducting the mutation operation. So I can choose the sixth serial number, I mean sixth population. In that second random number is 9. In sixth population I should consider the ninth bit value. In this problem I have 0 as the ninth bit value. So I should convert this 0 it into 1. Yes, I convert this 0 to 1. So I can create the new population with the aid of mutation operation like this, which is the initial step. But I have the 8 mutation sites. For the reason I should generate the next pair of mutation sites. Yes, 3 I got for random number 1 to 8, and I should consider the third serial number because of I got 3 as the random number. After that 9. So in third serial number I should consider the ninth bit. In ninth bit there is 0 available. I should consider that 0 it into 1. Yes, I convert this 0 it into 1. I converted that 0 to 1. Likewise I perform the next pair. Then I should consider the second population. In that what is the bit value? That is 13 for according to our second random number 1 to 16. In that I should choose the 13th bit. In that I have 1. I should convert that 1 to 0. Likewise I convert the bit values. Then last pair, which is fourth pair, the fourth is the 9. So that I should consider the 9th serial number. In 9th serial number the 7th bit represented with the random number 2. So I should consider the 7th bit, which is 0. So I convert this 0 bit to 1. Likewise I change the bit values that is available with the crossover substring values. I converted here 4 digits I converted because I got the mutation size as 8. So I divide this 8 into 4 because I got the 2 substrings. So 8 divided by 2 I got the 4 mutation sites. From this I can perform 4 mutation changes, 0 to 1 or 1 to 0. Likewise I perform. What is the next step? Yes, after mutation, here the mutation site available, mutated values are available. Now we should convert this binary value into decimal value. Let's see. Here again I form the table. Here I got the real number 90. How can I got the real number 90? Here see 0 1 0 1 1 0 1 0. Likewise I got the substring value 1. So how can I convert this binary value it into decimal value? For the reason I can show you a video. From this you are aware how do we convert the binary value it into decimal value. Yes, you may press the mode operator that is available with your calculator. In that you press binary symbol. In that you press first the binary number that is you getting from your problem 0 1 0 1 1 0 1 1 0. So which is the binary number. You should convert that binary number into decimal number, which is the real number 90. Yes, now I may get the 90 from the calculator. Likewise, so I represented 90 here. Likewise I got the all other substring values. The same for substring 2 also. From this we can get the 10 pairs of population real number values. From this I can identify the x1 value from the initial formula. x1 is equal to x1 min plus x1 max minus x1 min divided by 2 power l minus 1 into random number 1. Here random number 1 is called as a real number 1. I substituted the 90 for random number 1. I can get 3.1765. I may use or utilize the same formula for identifying the other values also. From this I can calculate the x1 and 10x2 values from the available formula. I can substitute the same x1 and x2 value with our objective function, which is maximization of z is equal to 2x1 plus x2 power 4. From this I can get the f of x value, which is the simple calculator function. So I can get the different values here. Maximization problem, so fitness function is equal to f of x. So the same, I reproduce the same f of x value as the fitness function value. Now I can get the complete the first iteration. From 0th iteration, the initial step is serial number 1, random number 1, random number 2, substring 1, substring 2, x1, x2, f of x, and then finally fitness function. Now you are aware about what are the steps that are available with the 0th iteration and how can we identify the maximum value. According to our first iteration, if I compare all other values, 150.7503 is the maximum value from other values. So that which is the maximum fitness function that is available with our problem. And also I can collect the corresponding x1 and x2 value from the table. x1 is equal to 0.847059 and x2 is equal to 3.494118. Likewise, we may conduct and we may identify the maximum value that is available with the 0th iteration. After that we can move to first iteration. In that also, how can we identify a, capital B, capital C, capital D, capital E, and how can we perform the reproduction, how can we perform the crossover, how can we perform the mutation operation, you already aware. From this we can identify the real number. After identifying the real number, we may calculate the x1 and x2 value. From this I may get the f of x value. From this I may identify the fitness function value, capital F. From this also I can compare all other values. From this I can get 3574.807 is the maximum value that is available with our first iteration fitness function value. So the solution, I may plot the graph. In x-axis there is a number of iterations. According to our problem, 0th iteration and first iteration, there is 2 iterations available. In y-axis there is fitness function value. The first fitness function value is from 0th iteration. I got 150.7503 and the corresponding x1 and x2 value is 0.8470 and 3.494. Likewise, x1 and x2 values I got. The same I represented here, and from first iteration I got the fitness function as 3574. The corresponding x1 and x2 values are 2.75 and 7.729. So I represented with the plotted graph. If I consider 100 population, means we should plot the graph. From the plot only we can identify the maximum value. From this I can identify 3574.8 as the maximum value for considered problem. The corresponding x1 and x2 values are 2.7529 as the x1 and x2 as 7.7294. Likewise, I may collect the maximum fitness value function from the available problem. Here 0th iteration maximum fitness function is 150.747. First iteration maximum fitness function is 3574.807. So the maximum value occurs at the first iteration than 0th iteration. Here the first iteration values, f of x value is 3574.807 with x1 is equal to 2.7529 and x2 is equal to 7.7249. for the considered objective function of maximization of z is equal to 2x1 plus x2 power 4 with subject to the constraints 0 less than or equal to x1 comma x2 less than or equal to 9, which is the problem linear part programming that is available with the objective available with the industrial problems. We can solve these problem through this genetic algorithm technique by the way of this procedure. If you are having any doubts, you may ask me through comment box. Thank you all.